Good afternoon, Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded IoT teams for Embedded Computing Design. I'm here for this week's Embedded Executive Podcast, and this week my Embedded Executive is Surajka Jendra, and he is the Vice President of Automotive Products for ARM. How you doing, Suraj?
Doing good, Rich. How are you doing?
I'm doing just fine, thank you very much.
Nice.
So, where I want to go with this, we spend a lot of time discussing the software-defined vehicle. And in most cases, the people who we talk to are people who are your customers, like
Right.
the NXPs and the STs of the world. And they have a finished solution that they obviously want to sell. So I thought it would make sense to talk to the guy who's actually guiding those people and I'd like to hear your perspective on where you think the software-defined vehicle is headed, because you're actually dictating it. As much as they like to think that they are, we know it's really you guys who are dictating it. And I know you get guidance from them as well, and it's not done in a vacuum. But let's hear right from the horse's mouth. Where do you guys see this thing headed, and in what time frame?
Perfect. Thanks for this, Rich. I mean, let me in fact start with all the way from the consumers, right, and then walk back to what we think about software-defined vehicles. So, at a high level, right? I mean, when I say consumers, it's technically you and me who drive the car, or who sit in a car that most likely drives itself a few years down the lane. But fundamentally, our experience, the expectation of the experience that we're going to have in the car is, hey, there needs to be over-the-air software updates, new user experiences, new features, new ADAS capabilities, and all of that stuff naturally sort of, delivered to the car over the air, without, having us to be sort of, forced to drive the car to the dealership, right? So software-defined vehicle is pushing new capabilities and experiences to the car over the air, right? In simple terms, that's what software defined is. I mean, essentially what people do with a cell phone today, right? I mean, we get software updates, we install new apps, we use the phones in different ways to try and basically get new user experiences. So that's the consumer expectation, right? Now, if you think about it from an OEM perspective, right? So
Well, let
OEMs
me.
want,
I'd
sure,
like to interrupt you.
yeah.
Is there a consumer expectation, or in the Microsoft world, every time I turn on my PC, it looks different? Do the consumers just accept what we give them, or is there an expectation that we're trying to fulfill?
So, I mean, that's a very good question. I mean, the thing, see, what the consumer expects, especially it's a car, so there's life at stake here, right? So when we push some of these new features and capabilities, the expectation is it should work. It should absolutely work. It can't be sort of in a cell phone or a PC. Yeah, I mean, if we get a blue screen on a PC, you basically restart, right? There's no blue screen concept in a car, right? I mean, it's life and death, right? So
Mm-hmm.
so the expectation is really, yes, you can send me new user experiences, wonderful, but make sure it damn works, right? So that's the really important expectation that's already there, and it's important to have that. Now, see, the OEMs think about this as, okay, software-defined vehicle unlocks new revenue streams for the OEMs, right? I mean, for example, new applications, new user experiences mean that, they actually sort of can still draw revenue out of the car even after the car drives out of the dealership, right? So that's a new sort of revenue stream for the OEMs, yet enabling new user experiences and features for the consumers, right? So if you really think about it, your first question was, okay, who is dictating, where this is going? And to me, I believe it's the consumers and OEMs, right, who are actually dictating where software-defined vehicle and what sort of features needs to go, what sort of capabilities needs to be enabled, and so on and so forth, right? Now, essentially, because of this expectation, because the whole automotive industry is moving at such a rapid pace in this evolution, um, there is massive disruption of supply chain, right? So we are talking to, the OEMs directly in order to try and understand what their requirements are. We are talking to tier ones. We always have been talking to the silicon partners. We are talking even more to the cloud service providers and software ecosystem, right? Because end of the day, if an OEM comes and says, okay, here's a bunch of user experiences that we would want to unlock and make sure it works. Okay. For this, here's the EE architecture that we have to enable. They come and talk to technology enablers like us directly and say, okay, what do you have on your roadmap? What's going on? What new features are you putting in, right? What safety capabilities are you enabling? How can we scale our compute performance from where it is today to what the car actually has to do even 5 years after it drives out of dealership, right? So that's why, so the whole supply chain is getting so disrupted, and we are getting to talk to everybody so that we deliver this final user experience that's actually needed.
How is it possible to
Mhm.
anticipate what might happen 5 years down the road when we don't know 6 months down the road? If you're using the consumer type of
Yeah,
application.
exactly. I mean, that's definitely a real problem, Rich, because I mean, technically, when you think about, okay, and I'm enabling a platform in a car, I would want to sort of have, uh, applications that are not even developed today to be able to run on this platform 2 years down the lane or even 6 months down the lane, right? So it's not easy for anybody to say, okay, here's how much compute you need to put in the car. Here's how much, here's the speed that your processor needs to run. Here's how, here's the bandwidth that you have to support through your interconnects. It's not easy, but what we can do by working closely. And that's why we actually engage with OEMs directly, because see, generally the automotive product development life cycle is, once we develop our IP, there will be a silicon partner who would actually take the IP and build silicon. So normally it takes about roughly 12 to 15 months after we deliver them an IP for them to tape out a chip and make that chip available for software development, right? Which we are changing now, by the way, and I'm going to touch upon that later in the podcast. Now and then, there will be workloads developed on them. The OEMs will get their hands on it and then basically start doing their qualifications and software development at a system level. So roughly, it's about 3 to 4 years of production or development life cycle, right? Now, what we can do is, in order to understand roughly at a high level what sort of performance levels are they actually looking for in that particular model year, we try to build as much scalability as possible, right? For example, okay, can we actually build a system with 24 cores instead of 8 cores? Can we build a system where each of those clusters of 24 cores can be connected in a chain so that 24 becomes 48 if needed, 48 becomes 64 if needed, right? So we build those scalability configurations in place so that, as the compute performance increases, as we drive new user experiences and use cases, we'll then be able to sustain and support the compute needed, right? Those are the different sort of angles that we use to try and still meet the future compute requirements, but at the same time, make sure that we start from the building blocks.
But your technology is only as good as what your customers do with it. You enable them,
Mhm.
but unless they take advantage of this stuff in the way they need to take advantage of it, it
Yeah,
doesn't do what ARM is expecting it to do. Is that fair?
absolutely. It is fair. It's absolutely fair. And that's why, right? I mean, and when I said we talk to the OEMs, end of the day, we do work with our silicon partners very, very closely, right? So in the sense that, when we work with our silicon partners, we would basically say, okay, look, this is the feedback that we've gotten from the OEMs. Here's where this probably is going. Hence, our roadmap is basically varying in such a way in order to go meet those OEM requirements. But then we work on a daily basis, work with our silicon partners to ensure that they also implement some of these features. At the same time, we support them in order to any sort of configurability that we want. For example, when ARM develops an IP, we actually put in different configurations, right? So one silicon partner will take, say, a bunch of configurations and say, okay, we're going to do this, right? And then we will work with another silicon partner who would say, okay, these make sense, but I would also want to do this, this, and this. And then we work with them and help them as well. So it's, you know, again, for us, everybody in the supply chain is important. We take inputs from everyone and try to make sure that the core technology is enabled with those requirements. But yes, you're right. As you said, our silicon partners have to enable those features using the capabilities that we've built in, and we work with them in order to make that happen as well.
And is it potentially uncomfortable because you're sort of like in the business world, you talk about going over somebody's head. You're going over their head by talking to the OEMs. You know, you're talking to their customers. So, I don't know if it's with them in the room or without them in the room, but then you go back and to your customer and say, "Hey, this is what your customer told me that they wanted. Why aren't you providing it?"
Yeah, no,
Um,
I think it's slightly more healthier relationship than that, Rich. We in fact in a lot of cases we do talk to OEMs with our silicon partners and software partners in the room as well with us, right? Because end of the day, again, ARM, as you said earlier, right? We have built this vast ecosystem in automotive. ARM has been present in automotive for the last over 30 years, right? And we've been able to build this legacy of having ARM-based compute across all parts of the car, primarily because of this ecosystem of partners that we've been working with, right? So again, our intention here to basically go talk to OEMs and other partners is primarily to understand the use cases. How can we understand those use cases to make our IPs even more capable and then help our silicon partners to grow? I think that's basically the mantra so far. And hence, that's pretty, I mean, the silicon partners actually, in some extent, basically encourage us to talk to some OEMs because then, we will understand the use case better, right? Then they translating it us from a different angle, right? So I think it's working very well, and we are pretty glad that we get this opportunity to learn from everybody in the ecosystem.
okay, there's a couple of things I wrote down that I want to
Uh-huh.
circle back on.
Mhm.
One is over-the-air updates. That
Mhm.
to me is the scariest part because at some point you're opening the door to bad guys,
Yeah,
um, and even non-malicious people who just screw up.
right.
How do you make sure that those updates happen the way that everybody intends them to happen?
Absolutely. Let me answer this in two parts, Rich. First part, let's just talk about what is needed for what sort of a software infrastructure is needed for us to enable over-the-air updates, right? You probably must have heard about the SOFI initiative that we initiated about 2.5 years back, right? I mean, September 21 is when we launched SOFI. Again, the whole intent of SOFI was to try and standardize some of the low-level, non-differentiating pieces of software so that we can have a very healthy software ecosystem on top of the non-differentiating pieces of software where partners can differentiate, yet be able to, have their code portable from one ARM-based solution to another ARM-based solution, right? Now, and that's all in the car, for example, right? But at the same time, what Sophie also did was drive a cloud native narrative. That is, have a similar sort of standardized software framework in the cloud. So for any of the software developers, be it within the OEM community or even general software ecosystem, to be able to enable and develop their software in the cloud. If we provide a similar environment in the cloud, there is a much better sort of infrastructure that we can enable. So, for applications developed in the cloud to be seamlessly deployed onto the car without recompilation or any of that stuff, right? Now, given the fact that ARM is in the cloud and ARM is in the car, right? It's ISA parity between the cloud and the car. So we have ARM-based cloud instances now from AWS, for example, right? And other partners as well. So we have, this ISA parity that we've established where, if we provide the same software environment, application developers can then utilize that environment and that ISA parity to deploy more seamlessly those applications onto the car. So that's the infrastructure work that we have been focusing on, and we will continue to focus on enabling. And you brought up a good point about security, right? Absolutely. So functional safety and specifically cybersecurity are two very, very key things. And I'll give you an example, right? So I have, a car, which does take over-the-air updates. Okay, and there is a, I got a notification a few months ago about a parking app. Okay, and I live in London, and the parking provider, service provider, basically sent me a notification saying, hey, uh, you know, my app is actually available on your car SDV platform, right? Like perfect. Okay, this is good. I mean, what does it do? It basically precisely will know where my car, what location it is in. I don't have to go search for the location code and then put it in my phone and stuff like that. The car will exactly know where it is, where it is parked, what the location code is, and it will download. It will basically let me pay for the parking in the console and all of that stuff, right? All straightforward, wonderful, beautiful, right? But the catch there obviously is there is a payment gateway system, right? The car then, I have to basically key in my credit card information in the car. So the car has to save, and there has to be a payment gateway mechanism securely basically handling all of this information, right? So the reason I'm giving you that example is it is not straightforward. There is a lot of vulnerabilities that one has to plan. Even the parking app developer has to think about. The vehicle, EE architecture and software architecture folk have to think about. I have to think about before I actually provide my credit card details, right? So now, yes, real problem, right? At the same time, I think there are, some of the learnings that people, that generally the industry has learned through cell phone and other markets. We can apply the same thing into the car, right? I mean, the other security vulnerability, situation is, I mean, you're driving on the freeway at whatever 60, 70 miles per hour, and you don't want to have any sort of security malfunction within the car that will sort of put your life at stake, right? So there is plenty of use cases that one has to be aware of. So we have been working with different partners in the ecosystem, be it cybersecurity software vendors or even cloud service providers, to make sure that the development and the deployment of the applications through the standard interfaces are done in a much more secured way, taking advantage of the new features that we are putting in the car. For example, ARM, CCA, ARM Confidential Compute Architecture is one good example where we are enabling end-to-end security realms, right, within the system that can ensure that one application doesn't interfere with other application and so on and so forth, primarily from a security standpoint. So there is innovation in the hardware and innovation in the software and in the ecosystem and in cloud, that I'm sure, as we sort of mature in this journey, we will be well protected. Sorry,
Okay.
that was a long answer, but
One more for you that's probably unrelated, but you alluded to shorter design cycles
uh-huh.
for your customers. What were you referring to?
This was, yeah, thanks for this. Thanks for reminding this. So let me give you an
I write
example.
stuff down because I don't remember anything. That was part of my notes.
That's all right. That's all right. So let me just start with an example. Let me start with so ARM, we refresh our automotive IPs once every 2.5 to 3 years. Okay, that's the cadence that we follow. We just did a major product launch back in March. We refreshed our CPUs for automotive. We
Why that
refreshed.
cadence? How did you come up with that?
Yeah, so good question. I think again, it also depends upon again, if you look at vehicle model year cadence and when the OEMs would want to refresh their platforms, it's roughly around 2.5 to 3 years. That's what they
Okay.
follow, right? And also it's roughly what it takes for the silicon partners to develop new SoCs as well, right? So we sort of we didn't want to do it on a day on a yearly basis, like what is needed in the smartphone market and what is needed in some of the other markets. But I think 2.5 to 3 years is sort of a sweet spot that also internally, that sort of was good for us to develop new products and sustain in the longer term, right? So we did a major product launch back in March this year. The previous ones was basically sometime in early 2021. Okay, roughly about March, April 2021. Now the first platform, Rich, that was actually developed using our 2021 IPs was available for software development sometime in the second half of 2022. Okay, roughly about 18 months later, right?
Hmm.
And it was basically sort of made available to the broader software ecosystem roughly in like early part of 2022. So a good 2023, sorry, good 2 years, 18 months to 2 years after we launched our IP. Okay. Now, and then of course, right, and the OEMs got their hands to it. They've been basically enabling their systems to it. And now we basically see, early POCs using our 2021 IPs coming out on the road. Okay. And that's a long journey, right? That's about, roughly about 3.5, 4 years. So now, what did we do is, I mean, we were like, okay, look, we have to cut down as much of this time as possible, primarily shift left the software development as much as possible, right? So this time we completely changed the strategy. On day one of our product launch, on March 13th, Rich, we basically had our EDA partners, okay, enable virtual platforms using our IP models and make that virtual platforms available in the cloud and on-prem for software development, right? Now, guess what? So we basically launched 4 different CPUs, starting from ARM Neoverse class CPUs to Cortex A's and Cortex, 2 different types of Cortex A's and then Cortex R. Now we made, like software development fast models for all of these IPs and on that day, okay, and the EDA partners were able to take those IP level models and build system level virtual platforms for software development. Okay, not just that. As I said earlier, we launched Sophie back in together with our partners back in September 21. And in the last 2.5 to 3 years, there's been a very, very good, healthy software ecosystem that's formed around Sophie standards. Now, all of the Sophie software partners in the ecosystem have already enabled their middlewares and software on top of this framework using our previous generation IP. Now, guess what? As soon as the virtual platforms for this new generation became available, most of our Sophie partners were able to make use of the virtual platforms because it was Sophie standardized. They were able to port their software written on previous generation ARM technology onto the new technology on day one. So alongside with us, and if you look at the press release, alongside with us, we had over 30 different software partners who enabled their software on day one, right? Their foundational software and middleware on day one available for anybody who would want to do application development. And we partnered with AWS specifically to try
Hmm.
and enable all of this infrastructure in their cloud, right? So again, talking about the ISA parity that I was talking about, right? So completing the whole picture of enabling a virtual platform based software development vehicle with foundational software enabled through our partners available in the cloud and on-prem for the software ecosystem to start their development on day one. So cutting the 12 to 18 months that I told about earlier, like, from 2021 all the way to second half of
Hmm.
2022, when the software platforms became available, that came down to zero. So literally cutting down the software development lifecycle from 18 months to zero, right? And then, of course, there is qualification, there is certification, and all the stuff that needs to go through. But the entire OEM community and software ecosystem don't have to wait for a board to become available for them to start their software. They can do that virtually, right? That is basically what we did, and we will continue to invest in to try and pull in our overall, development lifecycle.
Good stuff. That's very, very interesting. And I'm
Cool.
sure that the people we talk to on a regular basis are your customers, and I'm sure that they're thrilled to hear this news.
Cool. Thank you.
Well, thank you very much, Suraj. I appreciate you taking the time to educate the audience.
Thanks, Rich. Nice talking to you.
That was Suraj Gagendra, and he is the Vice President of Automotive Products for ARM, and I'm Rich Nass with Open Systems Media.